Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how to model pop-up buoy systems in ProteusDS. So first off, what is a pop-up buoy system? Sometimes they're called PUBs, pop-up buoys. They show up a lot in the oceanographic space, and here's an example from Mooring Systems Inc. on their website. And there's another example on Deepwater Buoyancy's website for a pop-up buoy recovery system. But they're also showing up, these are more ocean tech, oceanographic applications. They are showing up in other industries too. This is another company in Canada called Assured Innovations, and they have a system for the lobster fishery where these systems will, to recover them, an acoustic signal is sent from a surface vessel. A little release is unlatched, and then the float goes to the surface. So there's no lines in the water to entangle animals or foul ships or that are in the area or anything like that. And the similar kind of concept is a pretty universal concept. So similarly here, there's a release in here, and over here, you can actually see the release, the R500 Teledyne release in the float here. And when a release signal is sent from the recovery vessel, it'll unlatch, and this rope will, the float will go to the surface, the rope spools out. And then it makes it really easy to recover a frame or other equipment that you've got on the bottom. So that's what these systems are. And then how do you model all this in ProteusDS? Well, I guess the first thing to say is it's not actually that straightforward to model the unspooling of the line, and maybe that's a bit of it's a bit misleading to try to do that. I think it's not really that helpful. What really is helpful is when the line is fully out, do you have an idea, given the currents and the water depth where you're at, is your buoy going to be at the surface or not from the drag and weight on the system? If you can't see it, if it's not at the surface, it means you're going to be spending a lot of time on your recovery vessel, driving around looking for it, trying to find it, right? So that's something that is pretty easy and straightforward to do when you have the full line spooled out. So we'll use this as an example in this tutorial, and we're just going to randomly pick an option here. And what we'll do is open up Oceanographic Designer. So you can pick a new project, and I will pick a subsurface mooring, and we can go through and pick these things here, but I'm going to jump into it here and just make some changes in here quickly. So so just paying attention to this here, we have one rope option of 120 meters of 5mm line, and they what's typically used here is a 12-strand Dyneema rope. It mentions this on here. Here we are, and so we can change that out. We don't want to use wire, obviously that's really heavy. We'll change the line here to fiber rope, go down to AM steel blue is used all over the place. Just double checking, you can see here we have 12 strands Dyneema fiber. And I mean, what's key about this is the line floats, right? So it's not really going to be adding any weight to the pop-up buoy, which is really important. So we'll select that, and we got a 5mm size, just a little bit bigger than this. For 120 meter rope length, let's just make up, our environment's going to be 100 meters water depth for our little application here. I'll put in 120 for the length of rope, and we need to change the top buoy here. So what we'll do is, you can find this really quickly if you just type in PUB. You'll find the under flotation mooring systems, and we've got that little 16-inch pop-up buoy in there. Now this is a little bit different than the other ones because it does include the wet weight, the net uplift, it factors in the weight of the Teledyne R500 acoustic release. So normally you attach things to floats, but this is sort of a special case. So that's pretty much it, just for the recovery line. The last thing we need to do is just check the environmental conditions. So this default is pretty high. I mean, 2 knots is pretty high for a little float to recover in. But you know what? For fun, let's just leave it in there. And we'll maybe make a second case here for mild operating. and we'll edit these current values, maybe just to be sort of a quarter of a knot, you know, or 0.1 meters per second or so. And, you know, we'll leave it be still uniform flow. So a little bit, quite a lot more mild, more reasonable for attempting a recovery of one of these systems. So again, what we're going to try to do here is verify if we see the float at the surface or not. So I'm just going to make a little folder here, PUB line check. And now we can analyze. So I'm going to do a static analysis and export both of our current profiles. It'll open, I've made our little projects here in Simulation Toolbox, so I'm just going to run both of them. It should take a minute or two to do the static analysis while we wait. All right, so the static analysis has finished, and let's check the strong current case just to see what's happening here. So we do have more line than is in the water. Remember, it's 120 meters line in 100 meters water depth, but this is such a high current, and the flotation's not, you know, massive. I don't expect we'll see this at the surface, but let's see. So we got a nice side view here. This is the input format. It's just a diagonal line. This is the profile in zero current. You know, okay, we're all good. You got the float at the surface here. But then in the current profile, it's well below the water surface. So in these kinds of conditions, you know, you would not reliably be able to see the float or easily recover it. So, but that's a very high current at 2 knots. Let's check the results in something much more reasonable, like a quarter knot of speed. So again, this is factoring in the drag from that on the system. And we'll switch to engineering view here. Maybe I'll just make this a little bit bigger. So here we have the side view, just the input format here. There's the zero current condition. And then, hey, looks like the float's at the surface here. Pretty visually, obviously, we can see here. So that's great. You know, we got a really nice verification that very good chance that we'll be able to see the buoy, recover the buoy in speeds like this. So, of course, you're, you know, not limited to looking at only this speed. You can play around with it and see what else you can do, depending on what your particular problem is like with ProteusDS. All right, that's all for now. Thanks for watching.